And I want to welcome you to our expert breakout sessions for Mobile and IoT Summit. This is the session for Red Hat. And with us this morning, let me reintroduce our great experts, Connor O'Neill, Product Manager at Red Hat Mobile, and James Kirkland, Chief Architect for Internet of Things. Gentlemen, good morning.
Good morning. Thank you very much.
Great to be here. Thanks, Vance.
Yeah, we're really glad to have you here. Connor O'Neill has long believed that mobile plus cloud can be used for fundamental business transformation and works with all the teams inside Red Hat to lay out a compelling roadmap for the industry's cloud-powered mobile application platform for great flexibility. He was actually product management director for Feed Henry, which, as many of you may know, was acquired by Red Hat last year. And he brings 20 years enterprise software experience, including senior management with Philips, Xilinx, EMC, and others. And James, for his part, also brings 20 years experience. He is currently Chief Architect for the Internet of Things and Intelligent Systems at Red Hat, and in fact was an early pioneer in IoT. He has actually been working on IoT apps and solutions for transportation and energy customers for at least 6 years. So we're really glad to have both of these great experts with us this morning to discuss mobile and IoT. And in fact, in their session, From Mobile to the Internet of Things, 4 key considerations for the future of app development, James and Connor will address the challenges of both types of disciplines and what enterprises face across the life cycle to make impactful apps, from design, build, run, and even secure. And just a quick reminder, if you haven't already done so, you can download the Red Hat slides as well as some other great downloads right here in the links that are available under this viewing area. And we love your questions and comments. So to connect with our speakers, just type into the Submit a Question box. Now, gentlemen, it's time to hear from you. Tell us more about From Mobile to the Internet of Things, 4 key considerations for the future of app development.
Thanks, Vance. In the beginning, we'll talk about generically the challenges of mobile and IoT and what you're going to face. And the first is that these are new technologies and new stacks, and the governance and the use of these, it's immature and growing. So you need to pick very carefully the technologies you're going to use and how they integrate with not only each other, but with the back-end technologies in the data center and the cloud, especially on the device side. They can't be picked in a vacuum. You're going to have a heterogeneous app and technology and landscape. You're going to have a lot of different things. You need to pick technologies that are going to be open and interoperate with each other and support different standards so that they can communicate with each other and you can exchange data and control. And it's also balancing agility with stability, right? You need to be able to be agile and give people the data and the services and so forth that they need, but it's got to be stable and secure. It's got to be something that is not going to come back on you. You're not going to have customer data compromised or the system is going to be unstable and go down. You're going to need to engineer it to handle the loads in a safe and secure manner. With security and management, you're going to have those for the application lifecycle and the device. You're going to have an integrated system that manages these for the long term, taking devices and plunking them out on the edge and not touching them for 10 or 15 years is not going to work. These are connected devices that are going to have to be updated and managed, not just for security's sake, but also to take advantage of, over the life cycle of the device, the improvements in software and the software development life cycle giving you advancements. You're going to have to update these devices somewhat regularly. A big issue is the data avalanche as well. You've got to decide what data has use, how long it is of use, how you have to secure that data, and where it needs to reside. And so that data avalanche has got to be tamed by breaking it into chunks, and those chunks are going to have different characteristics. So you've got to segment your data. You've got to have sort of a schema around it so that you know what the security context is for it, what the life cycle of it is, all those sorts of things that we've talked about. And then there's the rise of shadow IT. There's a lot of organizations where they're just spinning up an instance in the cloud or a cloud service that IT doesn't even know about. And suddenly it goes down and you find out that it's critical and that it's being used for critical things. So there's got to be a way to integrate and onboard shadow IT, especially with the bring your own device environments that we have today. And you have to deal with flat or decreasing budgets. You have to deal with all of this stuff without getting additional dollars. So you have to look for the most efficient way to do it. And it's got to be integrated with the life cycle and workflows that you have today. A great example of this is METEORCOMM. Red Hat's been working with them for years to help build interoperable communications infrastructure for the freight rail system. And so this system's got to be exceptionally reliable, but it's also got to be flexible and functional. It has to handle moving around security messages to locomotives and signals, has to be able to handle orders to stop trains and things like that. But it also has to be able to move at a lower priority business data that, while not safety critical, is important. So they used Red Hat Enterprise Linux, and they used JBoss messaging middleware using the AMQP, the Advanced Message Queuing Protocol standard, and then built on top of that to build this system that not only connects one railroad's locomotives and signaling devices to its back office, it connects other railroads together. So you have an industry-wide solution that's built on top of Red Hat and Red Hat technologies. Another great example is Saskatell. Saskatell came to Red Hat with a problem where they had a vast amount of streaming data that was coming together in a new analytics platform that they were trying to build to bring in this data, interrogate it, and act on it. But they didn't have an affordable way for storing this data over the long term. Then they began working with Red Hat and were able to solve this problem. So we're going to now go to a video that we put together with Saskatell where they describe the problems that they had and how Red Hat was able to help them solve them.
For me, I'm a Lego geek. My grandpa bought me my first Lego set when I was 2. That was 39 years ago, and my office at home is filled with Lego. My office at work has a few Lego sets. It's an important part of my life. And I like the analogy between Red Hat storage, where the base storage unit is a brick, and Lego is all about bricks. Saskatell has been around for 100 years now, and it's a case of innovate or die. And if we can innovate, provide our customers with new services, new features, it allows our customers to be more engaged with Saskatell, and it allows Saskatell to be more successful as a business. Because we're owned by the government, our stakeholders are actually the entire province, the entire population. It means that we are ultimately accountable to everybody in the province. We have to make sure our services are available to our customers 24/7. We have to make sure that security, both in terms of our customers' personal information and their communication services, are secure at all times. Prior to Red Hat storage, we simply had no cost-effective way to store massive amounts of the data that all of our network devices provide us. By utilizing Red Hat storage, we were able to quickly and easily solve that problem. When we decided to take Red Hat storage and move forward with a technical trial and eventually move into production, we prepared for a long, drawn-out experience. The exact opposite happened. Our technical trial took about 2 weeks because we couldn't hit any snags that we weren't able to handle quickly and easily. Aside from literally pulling the power out of the back of both servers simultaneously, nothing we seemed to do could phase the platform. If it's that stable when you're breaking the rules, it's going to be much more stable once you get into production and you're following the rules. The big benefit of dealing with Red Hat for Saskatell is the fact that when we're dealing with an issue, we deal with the same solution architect again and again and again, and they work together as a team. So if I'm having problems with Red Hat storage that's also affecting Red Hat Enterprise Linux, our teams work together. It's one email, send it to everybody, and then Red Hat runs with it and comes back with a concise answer. Because I've been dealing with Red Hat for several years, I've actually seen the importance of the open source methodology grow over the last few years. And it's not just a case of it's grown step by step by step, it's leaps and bounds. It used to be when you'd go to Red Hat Summit, hey, flag a guy down and talk to him. Now it's flag a whole bunch of guys down and talk to them and take their time. They're here to talk to you, the customer. It's grown from just being a, hey, we're Red Hat and we want to help you do cool stuff with open source, to, hey, we're Red Hat, we're open source, and let's do cool stuff together.
And now Connor's going to talk to us about SystemLink, which is another customer that we've worked with in this space. Connor?
Thanks, James. Yeah, SystemLink's particularly interesting for us because it does cover the two areas of IoT and mobile particularly well. So this is a company building an intelligent domestic heating and hot water system, and they approached us to deliver both on the IoT side and on the mobile side something that allows them to give their end users, their customers, a mobile application that can interact with these in-house heating units and the system that's there. It's worked out incredibly well for them. Everything is built around our secure cloud, and it really kind of showed where that intersection is and where things are going, that many of the types of challenges you have in mobile are also the types of challenges you're going to have in IoT, and you can solve them in an integrated fashion. So we're going to talk about some of these key considerations that you need to be thinking about when you're talking about both mobile and IoT, or the transition from mobile into IoT. And the first of those is obviously back-end integrations. This has been one of the main challenges of enterprise mobile application development. You have developers building employee apps. These need high-performance, agile ways of connecting those apps to things like databases, ERP systems, CRM, and really, a multitude of other data sources and data sinks. And what you have really is a large number of simultaneous connections that need to be supported. And the data transfers there in a mobile context have to be lightweight, they have to be secure, and they have to be reliable. And whilst the devices and the payload content may be different for IoT, all of the same challenges remain. In this case, you have a wide variety of distributed devices that need to send and receive data from enterprise systems. And most of these enterprise systems are sitting behind the firewall. And many of them have been in use for years. And they weren't architected for access by such devices, let alone being accessed by mobile. So the question is, how does an organization achieve these types of integrations really without rewiring everything from scratch? So it turns out that there's actually no need to rip and replace your existing or legacy system. So whether you're fully on-premise, you're doing hybrid cloud, or you've done that transition, you're beginning that transition to the cloud, you can really take advantage of the same types of approaches. So an MBAS, mobile backend as a service, living in the cloud or living on-prem, can quickly and securely unleash all of those data assets. You can take full advantage of your PaaS investment too by easily deploying your MBAS into a PaaS. But it's really where you start taking advantage of what an MBAS gives you. Auto-discoverable RESTful APIs, API management, a microservices architecture, and a pluggable, extensible platform that uses technologies like Node.js and the Express Web Framework. It gives you the ability to deliver on mobile and IoT projects with a much, much increased velocity. And all of the modern tools that your developers have come to love are available to them to connect both mobile and IoT devices to your systems. So really an MBAS makes it a natural bedfellow with traditional ESB and integration products. And we'll talk more about that later on in the presentation. So standard tools offer high degrees of flexibility without lock-in, but they also deliver something even more important, and that's security. And I'll hand back over to James, who's going to dig into some of the aspects around security.
Thank you very much, Connor. So security and general management of the environment is really, really important. And I think that's one of the really key roles that IT is going to play, because a lot of the operating technology side of the business hasn't had in the past experience with these types of things. So I think that the IT organizations are going to come in as enablers and teachers and help these organizations understand holistic security and how you design security in. They're going to help create an environment that has security from the device to the back end by doing things like standing up certificate services, standing up potentially things like DNSSEC, and those sorts of things that the devices can then be engineered to take advantage of. Also by creating things like VPNs and NAT and different networking environments that can also be secured. And then at the back end, also, as these devices come in, authenticating the devices and making sure they are who they say they are as they connect to the back end. There's also a secure proxy layer so that you can proxy through rather than having a direct connection between these devices. You can proxy data in between them without opening your back end up. And as I mentioned, user authentication and device verification, user authentication and specifically on the mobile side to make sure that the people are who they say they are, and then device verification at a mobile and an IoT level. At a mobile level, to make sure the device is an authorized device, whether it's a tablet or whatever. And then from an IoT sensor standpoint, you want to make sure that the sensors are authorized to be on the network and haven't been tampered with and are still authorized and able to act on the system. And then make sure that the data streams aren't tampered with en route. So whether it's policies of encryption or whatever, VPNs or however you do it, you need to make sure that they're not tampered with in flight. And a good example of that is the Stuxnet virus that hit Iran. The real damage was done because it tampered with the sensors and had the sensors give off lower RPM readings, I believe it was, than was actually going, and they had the devices spin themselves basically into pieces. They spun until they died, and they were able to do that because the Stuxnet virus was able to give off lower than reality sensor readings. So it's important, even if you think it's just a sensor and it's just a reading, no, it still can be very important. If it's a truck engine and you've got something that's forcing lower than actual temperature readings, you could have it melt itself or destroy itself. Organization-specific security policies, so you're going to have to enforce security policies, and some of these may be PCI compliance, HIPAA compliance. There's a number of privacy policies that vary from nation to nation. You're going to have to implement these policies depending on what the function of the device is within your organization, the types of data it has, where it resides. So you're going to need something that's going to be able to enforce these security policies in multiple domains with different policies depending on the data type and the location and things like that. And then lastly is the cloud deployment model. You're going to have to figure out, is this something where you want to put it in public cloud? Is this something that's important enough and key enough to your business that you want to run it yourself and deploy it in private cloud? Or is the information vital enough that you don't want to risk putting it on a public cloud? Although public clouds have made incredible strides lately, there are still people that, for certain types of data, just are not going to trust a public cloud. So I think it's important to weigh those decisions, both from a cost standpoint and a management standpoint, and also a security standpoint. And next we'll be discussing speed to market. We'll be talking about how you can engineer solutions that are going to get you to market fast, and I'm going to be turning over to Connor for that.
Thanks, James. I think speed to market is absolutely key here, particularly coming from a mobile background. Unlike traditional heavy-duty, heavyweight integration products, a modern MBAS is all about lightweight, agile integrations, and again using familiar tools, so not using proprietary single-vendor type tools. And mobile has been a real driver of iterative development to maximize speed to market. There's been a lot of stuff that everyone has learned about how to do this right. And the same approach really works beautifully for IoT too. APIs can start simply, they can be built upon, you learn your lessons, you figure it out, you take the feedback and you build up from there. And by taking this API-driven approach, using the types of best practices for things like self-documenting APIs, multiple teams can iterate in parallel, and then they refine their solution as they progress. So this is the modern approach to software development, but it works particularly well in mobile, and it's being seen to work very well in IoT as well. In Red Hat Mobile, we're all in on Node.js. We're absolutely convinced of its power and utility, and it has been an incredible catalyst for this agile approach. So more and more data has been published showing that Node developers can deliver reliable, high-performance and enterprise solutions much more quickly than many of the existing approaches. In fact, I've just come back from nodeconf.eu, the European Node Conference in Waterford, Ireland, and it was rife with these types of success stories. Indeed, one of the poster children for Node.js, Netflix, they have many of the same challenges IoT developers in terms of number of devices and so on, and they've solved many of those problems with Node. I suppose in the past year, you've probably heard quite a bit about two-track IT. It's a formalization of something we've seen ourselves with customer base in recent years. Fundamentally, it means that core IT focuses on delivering stable, reliable, secure core systems at their traditional development pace. They ensure that access is then made available to those systems via an integration layer like an MBAS. And this is why a well-architected MBAS fits in so well with traditional ESB and integration products. The fast IT then can consume these services. They can build agile solutions quickly, and they can respond to internal demands, internal line of business demands using an MBAS type platform. And they know that On the MBAS side, it delivers things they need like performance, caching, reusable microservices, reusable APIs, offline access, and mobile authentication. And then they can focus on getting apps quickly into the hands of users, and whether that's mobile apps or other more traditional type apps. But the interesting thing is IoT adds another layer, which is why we've coined the term trimodal IT. So here, in addition to core IT and fast IT, you've operational IT. And these guys are responsible for managing and securing access to the devices that are owned by the operational departments in the business. And indeed, the role of plant management begins to look more and more like an IT role with the advent of all of these data generating and data consuming devices. And the challenges these operational IT people have are unique, and they may be at a pace that's even slower than core IT, basically due to the physical and environmental issues that they're facing, which many of the others don't face. A core motivation in IoT is really to extract actionable information. I mean, that's just across the board for anyone diving into this. It has to be actionable. And that flow from device to mobile backend to message bus to big data processing and then on to business rules engines and beyond will deliver enormous business benefits and cost savings in the coming year. Everybody's aware of this. But actually, in addition to that type of data that's been generated by the device, its core functions, the metadata about the devices themselves is also critically important and can provide immediate insights at an MBAS level. So things like location, movement, activity, status, health, device health, these can all be very easily captured, aggregated, and they can be used both for strategic type planning but also immediate actions like maintenance. Indeed, in our own customer base inside the mobile group, we have customers heavily involved in large amounts of physical infrastructure that needs to be evaluated, checked, and data fed back so that maintenance can be applied on them. So this is a very common thing where, again, the mobile piece helps on the human side of things, and IoT is taking care of the M2M side of things. And I'll hand you back to James now.
Thanks, Connor. One of the key things about the IoT information lifecycle, and mobile is definitely part of this, both in generating and consuming data, is that the data that's emitted from sensors and mobile devices and things like that is really useless by itself. Without both context and analysis, it is just junk, but it's got to be processed in some way. We believe that it's going to be processed in two ways to be useful. And the first is that field level data analysis that's going to turn it into information. So it's going to be tactically analyzed, whether that's on a gateway, whether that's on the edge, or if it's in an MBAS, but it's going to be somewhere relatively close to the device. It's going to be analyzed, we think, by things like rule engines rather than in core code or in a big data analytics way, because it's action oriented. And there's usually a limited amount of time where that action can take place. So it's going to have to be something that is relatively quick. Those predefined business rules are then triggered when you have certain things come through, whether it's temperature, whether it's a customer taking certain actions, whatever that is. And those business rules will act to optimize, whether it's to shut down the piece of machinery that is misbehaving, whether it's to offer a coupon to a customer, whatever that behavior is, it's going to be triggered based on the analytics and the rules that are around it. Next will be intelligence, and that is basically there is a subset of that information that's going to need to go up into the cloud and be processed, whether it's in Hadoop or whatever the tooling is. It's going to be analyzed to look at A, the effectiveness of the rules that you have, and then B, look for new correlations that can be turned into rules. So you're looking to optimize what you have today, and then also look for new ways to optimize the system based on the data sets that you have, or you may get new data sets that come in that cause you to look at information in a different way. And then that's going to be turned back into business rules again. When you find these optimizations, you're going to turn them back into business rules that are then deployed through a rules engine back out into the enterprise, both at a device level and potentially in the cloud as well, and in an MBAS for your mobile devices. So it's important that you not only take this and take tactical action, you take it and you look for the strategic optimizations, but that you then funnel that back in. If you're just relying on code to do this, then you've got to go back and you've got to recode your application. You've got to go through release testing. Whereas if you're using business rules, you're able to go ahead and just deploy the rule change You still have your core application logic intact as it is. It's just that that logic interacts with the rules engine, and so it gives you a more agile way to add these optimizations to the system. And now I'm going to hand it back over to Connor to talk about the future and where things are going.
Thanks, James. Yes, we absolutely believe that the types of approaches we have been taking around MBAS and also around PaaS and how you actually deploy an MBAS itself will really simplify development and make code deployment much easier in an IoT context. But also those involved in mobile development using these types of technologies, these types of approaches, these types of agile approaches to things will be able to quickly transition to the IoT world. Everyone's seen the spectacular growth in the use of containers and microservices even in the past 18 months, 2 years. That's particularly been true in mobile backends. And again, we're going to see the same thing happening on gateway IoT devices because this type of approach, particularly this type of deployment and operational approach, gives you what you need to get the job done and do so without the traditional bloat of enterprise stacks and the slowness and everything that's involved there. So we believe that the solutions which will succeed in the market, they'll be differentiated around these areas of security, compliance and traceability. They're just absolutely critical to any success here and making sure that IoT is something that's going to succeed in a wider context. And it boils down to really, at a very, very basic level, to bi-directional data delivered quickly and securely end-to-end, and then building on that and everything else that you do. So there's a few links we have here to finding out more about Red Hat, finding more about mobile and our IoT projects. There's 2 particularly good resources there we'd encourage you to read. And obviously, if you have any questions at all around any of this, please get in contact with us. So that concludes the formal part of our presentation. I'll now hand it back to Vance to see if there's any questions.
Excellent. Connor, James, a really great session, and you really covered quite a bit, and especially like the customer video there. It really put some of these moving parts into perspective. Really great session. Thanks.
Thank you.
Thanks, Vance.
As you might expect, we've got quite a number of questions that span the gamut, both from big picture as well as implementation. So with your permission, let's dig right into them.
Absolutely.
Excellent.
You mentioned MBAS quite a bit in common for both delivering solutions for mobile and IoT projects. If we want a common platform, such as an MBAS, for both our mobile and IoT initiative, how do we think about designing and delivering that?
Well, really where we've come from over the past few years is settling on, even as a base technology stack, Node.js and the ecosystem that's around Node. And the reason for that is it's not specifically to do with the language or anything like that. It's simply the performance capability and a design of a platform that is focused on performance and the ability to handle lots of data streams simultaneously with aplomb and with low resources, because everybody wants to do things in the most resource efficient way. But you then take that and look at IoT, it just becomes so much more important again in terms of being able to deliver this type of platform and that type of performance easily. And it gives people a base that they're very familiar with and that they can deliver IoT and mobile type applications simultaneously. The areas where you're going to see lots and lots of development around things like low-level protocols and so on, so that they're optimized for low bandwidth scenarios. But in terms of addressing sort of the core requirements, that's why we've headed down that particular road when it comes to delivering an MBAS.
And it's important to remember that the MBAS is just one part of a broader solution. The MBAS will also integrate potentially with our PaaS OpenShift applications that may be running in JBoss EAP, or it may take advantage of services from Fuse, AMQ, BRMS, and a host of other services that are out there. So the MBAS isn't an island unto itself. It will satisfy a lot of the requirements, but there are also other services within the broader IT environment that you can take advantage of as well to integrate other applications that may pre-exist.
So let me put one question to you this way for the developer side of the equation. It simply says we already run many of our mobile apps or design them with APIs, HTML5, or natively. If we want to move to IoT, it sounds like we need to do more than just count on smart front-end tools or wizards to get to that point. What do you suggest?
I think it's a good question because I think that one of the traditional views of, we call them app developers, mobile developers, they tend to be lumped into this front-end developer view. And I think that has changed a lot. The idea of just purely front-end developers who just do UI and just do UX, those people still exist. But what you're seeing is a much broader set of skill sets out there from developers. And particularly as we have gone down this road of RESTful APIs and API-driven development, a lot of those type of developers think API first. So they're thinking, what is it I need to provide on the back end so that I can then deliver that inside my mobile UI? So in an IoT context, absolutely, there's a lot of the skills that they would use that possibly aren't appropriate in many cases. Traditionally, when you're talking about IoT, you're talking about embedded development and embedded devices. In a more modern IoT view, you're obviously talking about gateway devices as well. But that back-end piece, and particularly, and again, I should stop banging on about Node.js, but Node.js is JavaScript, and front-end developers know JavaScript. So what you have is a lot of these people actually have the core skills to be able to transition over to IoT type projects, not seamlessly, but at least they have some of the core that they need.
Very good. And James, I think this conversation that goes to the integration infrastructure expertise, let me kind of follow up from the developer conversation with this. How does Red Hat see the MBAS architecture working in conjunction with API management or even capabilities for huge amounts of data transfer? And relatedly, you mentioned the convergence between Feed Henry's technology now that they're under the Red Hat umbrella with other JBoss products for BPM rules and such. Can you put a context into that part of the IoT infrastructure?
Yeah, so I think what you're going to see at a minimum is you're going to see AMQ, which is the JBoss message broker, be used as enterprise message bus that's going to take data from all of these sources, whether it's the MBAS, whether it's other applications to IoT, and it's going to be the routing engine that's going to move that data around to where it needs to be stored or consumed. You're going to see JBoss Fuse used to aggregate data, transform it, route it, so it rides on top of AMQ. And it's the intelligence that helps you manage the data, get it to the right place, get it normalized and batched and transformed in the way that it needs to. And then you'll have the ability to use BPM Suite or BRMS to then act on that data. Those rules may be deployed out to a gateway in the field, but the actual tools used by the business analysts and the developers are going to be in the data center. So they're going to look to this data that comes through Fuse and AMQ from all these different sources that may get analyzed in Hadoop or some other analytics platform, and then they're going to use that to craft those rules in BRMS or BPM Suite in the back office and then push and deploy them out either to the mobile environment or out to the gateways and into the IoT environment.
That's a great image of how the future of integration will play with both mobile and IoT. Another issue, as you guys have mentioned in your session, is security. That certainly came up here too. And the question is kind of an interesting one. If we're looking to have a security solution converge for both mobile apps and IoT data, is there a simple way to do it? Does the architecture require a gateway? Do I encrypt the data before I send it, or on the fly, or what?
So I think that you have to have a layered defense when it comes to security. You have to have the data itself. You have to make decisions as to whether it's encrypted just in flight, whether it's encrypted at rest as well and just stays encrypted. Encryption in flight's typically through SSL, whereas you can encrypt the actual data itself. It's a lot more work. And so data encrypted only in flight may be data that like sensor data and things like that, whereas data that's encrypted at rest may be control messages, it may be personal data, say medical data, or business critical data, those sorts of things. It's also important that you have a lot of other things around that. You're going to need to have code signing and patching and things like that that manage what executes on the system. You're going to need to have a certificate system or some other system that authorizes the systems and other actors within the architecture so that you don't have somebody that is injecting themselves either through a man-in-the-middle attack or by taking over a system and tampering with it. But you've basically got to have these layers so that you know at some point something is going to be compromised. You're going to have a sensor or a smart meter or something that gets compromised. The real thing is to not let that compromise all the systems that are around it and then compromise the cloud. There was a retailer that recently had a point-of-sale system, a large number of point-of-sale systems get compromised and had credit card data stolen. An initial attack came through an HVAC system. So it's not enough to just secure the HVAC system. You also have to have a secure environment around it. You have to have VPNs and firewalls and have to have the other systems secured. And it's important to have layers of security because you will have individual spots that do get compromises that you're able to localize that, detect it, and then act on correcting it.
Also things like fine-grained access control. I thought it was particularly interesting what James said there, about just because you can exploit one particular area, that doesn't then allow you to use it to get in further. So that's why one of the big areas we're focused on is the whole area of containers and making sure every single piece of the system is firewalled off from each other. And we talk about the sort of the end-to-end piece from device all the way through to back end, but there's also, I suppose, the top to bottom, which is everything from whatever back end code you're running down through your containerization system and down to the OS itself, that you're sure of the security of that. I think it is really important to say open standards and open source are really your best guarantee of securing whatever you're doing.
It's a good point. In fact, you mentioned open source, and even though time is coming to a close, I can't let you leave without a quick discussion of that. And a couple of questions came in that look at that very issue. First, are there open source projects, especially in IoT, that we should be paying attention to these days? And relatedly, does Red Hat, now that they own Feed Henry, plan to put any of their own innovative technologies into open source projects?
I'll take the first half, and then I'll pass the second half on over to Connor. The first half is, there's a lot, both at a standards and an open source project level. We participate in groups like the IIC, the Industrial Internet Consortium, and a lot of other standards bodies, because we think standards are the basis on which you then build open source. You have to have the standards first. So we're participating in MQTT, AMQP, a lot of these different standards organizations, and then we're creating projects for reference implementations. So you have projects that we productize, like ActiveMQ, which is productized as AMQ, Camel, which is productized as Fuse, and BRMS, which is the project that it comes from, is Drools. And we're integrating those with other IoT projects. So we've been doing a lot of work with the Eclipse IoT Working Group to integrate PAHO, which is their MQTT client, and Cura, which is their gateway services layer and device management layer, so that we have integrations between PAHO and AMQ. We have integrations between Cura and Camel/Fuse. We're not only participating in all these groups, we're also trying to integrate them with our products and potentially at some point maybe even productizing some of these other pieces down the line. It just depends on whether there's customer demand. Connor, I'll hand off to you for the second half of the question.
Sure, yes. I mean, we absolutely intend to fully open source what was Feed Henry. It's obviously a process that every acquisition that Red Hat makes goes through. Every acquisition takes a different amount of time. I think what's very handy for us is much of our stack was built on open source in any case, so it just makes everybody's life a little easier. In all likelihood, we'll do it incrementally, like we'll just carve off interesting pieces that we think the community would be particularly interested in early and make those available, but eventually the aim is that the entire stack will be open source, and the more eyeballs you have on a software stack, the better for everyone.
Really excellent news on that, especially the open source. And I know that the JBoss folks have long been big advocates of promoting the developer tools as well as the operational side of JBoss into the community to get kick the tire feel and look of how folks can use it. Are there things in this MBAS or IoT integration world that are available now for folks to download as a community edition?
From an MBAS perspective, you can actually go to openshift.feedhenry.com. It uses OpenShift Online as the back end where the actual MBAS piece itself executes. It's a really nice way of actually seeing the original core FeedHenry product working nicely with the Red Hat OpenShift product.
Yeah, and I'll add that developer.redhat.com has all the software that we've talked about, and it's available for developers to use with no charge. So as long as you're using it for development work, you can use all the tools that we talked about from a JBoss perspective. And then once you go to move into production, then you'd contact us, and we would work to make you a customer at that point.
What an excellent session. Great slides, great Q&A, and a goodie bag of downloads to boot. Connor O'Neill and James Kirkland at Red Hat, thank you very much for a great session, and especially for taking so many questions and giving us information about the open source roadmap and the free downloads. Thanks very much.
Well, this is great. I really appreciate it. And if you have any further questions, you can email our email alias internetofthings@redhat.com, and we'll be glad to answer any questions that you have.
Yeah, thanks, Vance. It's been an absolute pleasure.
Excellent. Really great, guys. And as we love to do here at the Mobile and IoT Summit, we had quite a lot of information in these slides as well as the Q&A, lots of material on both the mobile and IoT side. We got some links up here on this slide that are going to be available for you to help give you the one-click access to that information and code where it's available. And don't forget, we've got some great downloads here in the room itself. Thanks again, everyone.